So, my friends, today we're going to cover another aspect of C programming in some more details than we have done already. This is about using macros. We are going to continue today with another instance of the hash define function. Now, imagine that you have to calculate a complex variable. You have to let's say you have to calculate a complex sequence of operations. Alright? So let that operation be like this. Let's say we want to have x square plus 3ab then divided by x multiplied by say k and the whole of that divided by another quantity y, okay, which is then added to say 34 fg. Okay, so we have x square plus 3ad divided by the whole of x multiplied by k divided by y, and to this we are adding 34 fg, that means 34 times f times g. Okay, so you look it up like this. Okay, so it's a complex formula. Now let us say you would use it for several different variables, several different values of several different variables. Now instead of doing it, now let us say you have to do it a number of times. So obviously what we have done so far, instead of doing this, we simply make a function. So it will look like this. So let us say we have an integer function called solve equation. Open braces, close braces, and down here we are going to use all these variables. So let's just say that we paste this. Now here all we do is we do a return. Whatever the value of this is, we change this to an integer, because we are returning an integer, so we change this to an integer and we put all of this in big brackets. So this has to be x multiplied by x multiplied by x plus 3 multiplied by a multiplied by d, and this has to be put in brackets, of course. And here we have to add this operator, and here we have to add a multiplication sign, and here also a multiplication sign, and okay. And obviously let us not forget that we need to put a bracket here as well, right? Now we want to further bunch it up. You can go ahead and bunch it up like this. You can put this in brackets to show that this is a unit that needs to be done together. You can put this x multiplied by x in brackets also. And now here you need to pass it all the variables. You have x, a, d, x, k, y. That means x, a, d, that's 3 variables. K, y, f, and g. So you do oh, I beg your pardon, it's not B, it's D. And alongside that, okay, you also need to pass in between that, you also need to pass int K. You also need to pass, so A and D are already passing, so int K, int Y is there, and int F and G. Okay. Now here we need to specify something else also. So here there is a division. Now this division, okay, now if the denominator is bigger, then this will be immediately turned into a float. So you have to specify that this should be an integer division. So you need to explicit typecasting here. See, what I've done here is, let us say that 3 times a times d is smaller than k multiplied by x divided by y. Now if that is the case, what will happen? It will be turned into a float number, but that we don't want because we are actually multiplying with integers. So with the possible loss of some precision, we have allowed that. In fact, in this case also, we should be explicitly typecasting it into an integer. Now regarding mobile compilers like the ones that I've used, or rather I am using, it may be that it takes this typecasting also very implicitly, but we should not bank on that, because in C generally, that is normal C, that is standard C, this should be written like this. Once again, what have I done here? I have done int x multiplied by k divided by y. Why have I done that? Let us say that x multiplied by k is 5, or let us say that x multiplied by k is 6 and y is 7. Then we have a number called 3 by 7. Or if say x multiplied by k is say 9 and y is say 7. Then we have a situation where we have two whole number 7 by 9. Now you see, the point is that in that case, not two whole number, I beg your pardon, one whole number 7 by 9. So, no, sorry, two whole number 7 by 9. So, basically, what have we got here? 9 by 7 is actually one whole number 2 by 7. Beg your pardon, sorry, what am I doing? So, one whole number 2 by 7. So, 1 and 2 sevens. So, this is going to become a mixed number. Now, this is a mixed number, then it is not integer anymore. But we are dealing with it, we are returning integers, we are dealing with integers. And you see, we are returning an integer here. So, all of these must be cast into an integer before that is taken. So, that is exactly why I am doing this. In effect, if x times k is 9 and y is 7, here, if that is the case, then this one whole number 2 by 7, that will become 1. So all the integer parts will be taken. Now this has been done. Now let's see if this is compiling properly. Okay, there's a dot there, sorry. Yes, so it compiles well. There is no main function, obviously. That is why there is an error. That is okay. Now let us say that I have got a main function. Now I just want to print after calling fn solve equation with a few variables. Now what do I have? I have integer x, I have integer y, I have integer k. Let us just put this in that order. Integer k, integer f, integer g after that. Yes. An integer y. An a and d. Now let us assign some values to it. This is 3 semicolon. Semicolon is obviously very important, as you all know. If you don't give the semicolon, the statement will not terminate and there will be an error. So at the end of each statement we give a semicolon. sorry about that, equals to, let's say, 7. Just simply that. Now we can use another variable. So int result Now this will have to assign the question. Now so when we do result is equal to fn solve equation then we give it that those things. So beg your pardon. So xkfg, okay, let's see. What we have is xkfgyad. So we just give it those. xkfgya y a d. So whatever the local variation of all these variables is, bring it down and cut this and put it here. Mind you, see how I am programming. I am actually not initializing it with the function call. I am first declaring result and then I am doing it. This is the proper way of doing it. With results that come directly from a function, this is the proper way of doing it. So xkfgyad, as usual, xkfgyad, okay, fair enough. And then I will put a semicolon there, and obviously what remains now is to print the result, which is as follows. Just a backslash in. Result. Okay. Now then if we run it, that you got a result. Now whatever way you have actually implemented this 1581, this is the result. Process completed, etc. Fine. Now the thing is that, say if you want to call it several different times. So this is one, and another time, I beg your pardon, another time you may choose to use a different value altogether. You may just change the values. So we can just do it like this, that x equals to 6. In fact, let us just copy all of this Okay, we can't do that, sorry. So x equals to 6. Say k is equals to 78. Let's say, I'm just giving arbitrary values. F is equal to say 65. G is equal to 22. 22. And then y, that is equal to say 31. I'm just giving arbitrarily once again. And then a, that is equal to say 5. And d is equal to say 6. And now I repeat these two lines. Copy and basically paste it here. Run it. So another different result. As long as it is within the range of an integer, it will be fine. So basically, similarly, you can be using it n number of times. Once you've written the function, you can be using it n number of times. Now, what is the downside of programming like this? The downside is, as you can already imagine, the following sequence happens. So, when you use a function, what happens there is that one, the state of there is a calling function. Beg your pardon. Calling function has to be saved to, okay, the called function is executed and the result is dealt with and number 3, after the called function finishes, okay, we go back to the the calling function. Oh God, calling function, we go back to the to the calling function. After the call function finishes, we go back to the calling function. Okay, that means from where. So in this case, it is main. So for example, main, okay, and by reinstating the program variables from the data stack. There can be, in some implementations, there can be data stack as well as instruction stack, whatever we call it, a data stack, but the data is there. The state of reinstating a program, giving back a program state. Program state means that the value of all the variables of the program at a particular point of time. That is called a state of a program. So we do that. So after the call function finishes, so we go back to that, okay, and we do this. Now you see, all of this has to be done. So it is obviously a bit of an administrative problem. So there is another way of doing it. But this time around, we're going to also use something called a macro. And remember this, that macros appear right above any declarations or anything like that. It is a preprocessor directive. So we use a hash define. We use the name macro solution, and we just give it, or rather write it like this. So we have xkfg yad. So we just do like this: x comma k comma f comma g comma y comma a comma d, and this is the name of the macro. The entire thing is actually the macro instruction, and what it is to be replaced with is this text. Sorry. Oh. Please bear with me for 1 second. We copy this and we paste it here. But there are obviously some extra bits that I just copied, that need to be gotten rid of. Okay. See, there is no semicolon at the end of it. Just this code here. Okay. Which means that the text here is going to replace by the entire text here. Now, if I just copy this again and I just paste it. Now, instead of fn solve equation, I will just use macro solution and then I'll print the result. What will happen is, wherever this appears, it will be replaced with this. Wherever this appears, it will be replaced with this. So it's just a text replacement. So that is exactly why it's in preprocessor, that it happens before the compilation is done. That the preprocessor directive is seen, and the text to be replaced, which is this. This is the text. This is actually the text to be replaced. This one, this entire thing here, mind you. Oh, sorry, this has gone a bit haywire. I need to pull this up. Okay, so the text that is replaceable is the macro sln xkfgyd. There is nothing, there is no mention of integers or whatever, and the code that is to be executed is written as a replacement text. This is the replacement text. Okay, oh sorry, okay, so basically it is asking me to get rid of this keyword, so I'll just do that. I just get rid of this. Yeah. See what is happening. Is it a gap or is it something that okay, so I've actually got this thing now. Okay, sorry, so let me just go back to what it was before and show you. Actually, I was using a dot here. Well, I mean, I was just inadvertently using a dot here. It may not appear here. So anyways, like that, run it. And this time the name is wrong, so actually SLN. I will just change this. Okay, so there we are. Now everything okay. See, you got two 48662s at the end. So it's 48662, 48662. The last one was calculated using a macro. Now you may say that this is the same, but it is not actually the same, because what happens, let me tell you. First of all, when you use macros, then the following thing happens actually. 1. So the replaceable text is replaced by the replacement text, and it happens before compilation. That's why. So that is why it is a pre-processor directive. Okay, because of this fact. So it's just a text replacement. Basically, it is nothing but a text replacement that happens. That means your code gets written by the macro wherever the replaceable text appears. Replacement text appears there. That's it. That's all. Number 2. So compilation is then carried on with the replaced text. Okay, as if you had made it, as if you had made it. So you're only writing once and it is getting replaced multiple number of times, but the behavior is as if you've made it so. It is not so. It is actually not so. You've not made it like that. You've just used the macro instruction and the macro is getting replaced, but to the compiler it looks as if you have made it so. Then basically there is no need for function calls. Also, you can use it for different types of variables. Let me show you how. So let us say that instead of doing this, just one second. Let's say instead of doing this, I can also do, I can just say copy this, go down there, paste, and let me just use some constants now. 3.5, 9.8, 8.6, 6.45, 7.54, 5.56, 7.56. This is 7.52. And instead of printing it in result, putting it in result and printing it, I will be directly printing the result using this, that I will copy it entirely now. I will put it here. Oh, sorry, beg your pardon. Just one sec. No. So I'll just put it. Okay, I'll just get all of that. It's a bit difficult to operate using this phone, especially when the screen recorder is on, unfortunately. So cut this, and here I will just use the macro, and I will make this a float. Oh yes, of course. Once again, a bit of a mistake with the bracketing. Another mistake with the bracketing. Let's see whether I've got the bracketing. Because all the cutting and pasting, and this being a small sort of a space to work with, this is what happens. Oh yeah, there. Right, there you go. So 0.000. Now there is something wrong there, and we have that. But I would need to check upon it. But whatever it is, you see, when we are, I beg your pardon, when we are using a float value instead of a integer value, it is still taking it. So let us just see where it went wrong. So here, okay, the solution is this. So rather than this, I'll be okay. Let me get rid of these integers here. Let me get rid of all these typecasts in the macro definitions. Let me get rid of all these typecasts, so that whenever we are using the variables, because of the macros, let us see. There you go. 1925.803450. Okay. What was happening before is that I was using integers as before, because I had copied and pasted. So the integers were there, and the integer values of all the divisions, etc., were being taken. So obviously, somehow that was, say if there is a fraction, say 0.575, let's say, and if you make it an integer, what will be taken? 0 will be taken, and the fraction part will be dropped. This is what was happening. So anyways, now it's solved. Now, so there you go. So you see 48662, that is using the x, y, z variables, etc. So what is that? That is basically like that is used with the integer 1925.803450. Let us concentrate on the last two values. 48662, that is the macro use in case of integers, and 1925.803450 is macro use instead of in case of floats with the same formula. But why is that? Because we are just doing text replacement, so that the original values of the variables will remain. And you see, because it is text replacement, the x, y, z, etc. don't actually matter. What matters is what you pass. Okay, so let's have another go. Let's have another go. Let's put some float values in place. Copy this, paste this here, and instead of int, I write float. This will have to be changed. x1, k1, f1, g1, y1, a1, d1, float, 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 and lastly d1 also into a float. See how the text replacement actually works. Up here it is x, k, f, g, y, a. Here we have created x1, k1, f1, g1, y1, a1, d1. These are all floats. They're not even integers. In case you are using the fn solve equation function, obviously you wouldn't be able to do it because it is only taking integers, not floats. But in case of the macro, see, if I just copy this and we manage to paste this here, okay, and instead of these particular constant values, let me use the float variables now instead. So we have in sequence we have xkfgyad, right? xkfgyad. So x1, k1, g1, a1. So sorry, xkf. So we have a next one as well. f1 as well. f1, x1, k1, f1, g1, y1. So y1 and a1 and then d1. Okay, and we're just printing it there. 1574.000000. Well, that's because these are the values that we have given it. So the division system, so you may wonder, sir, why is it that it is 46 something in case of integers but it is something else in case of floats? Well, that may be because of the fact that we've given it whole number values, right? 3, 4, 5, 9, 5, 4, 7, just like before. This will be taken as 3.000, 4.00, 5.0, blah blah blah, and then what will happen is all the divisions, etc., where we were taking integers, we were taking, in case of the function, we were taking integers there to keep it integer compatible. We're taking the integers, whole numbers were being taken, but here the fractions are also being taken, and the fractions are being divided, the fractions have been multiplied, so all of that makes for a bigger fraction, and so on and so forth. So when we run it, we've got this value instead of 1581. See, this is the first one, that the values that we use, the range of values is this. For integer, it is this where the spot is appearing. That is actually 1581. but that is more precisely written as 1.574.000000 in case we are using the float. So all in all, you see that once you write it with a macro, you can use it for any variables as long as you give the equal number of variables as it appears in the macro. You'll be able to use it, and if you do not specify inside the macro whether it's an integer or a float, it'll be taking integers and float both as the case may be. Let's say, should we try to replace one of those floats? So these are all floats, these are all integers. Let us say if we try to replace a float with an integer, x is an integer, so let us try to replace x1 with x and see what happens. Okay, 1583.5000000. So it is taking, number is slightly changed. Instead of 1581, we are having 1583 by using x instead of x1. The reason being that when we are taking an integer, some of those zeros etc. may be approximated, or it may be that because of two different types of divisions being done and one different type of variable being handled, it may has varied slightly, but very slightly. But the main thing is that it is actually still working. So all I mean to say is that if you're using macros, you have got this flexibility. Let us change it back to x1. That's only proper. Yeah, 1574.000000. That's the one. Now, what happens with, so what is the advantage of disadvantage? Why do you have, in that case, why do you have functions? Basically, the disadvantage is as follows. So, however, it greatly increases program size. Okay. As opposed to when we use functions. The reason being because of the text replacement. Now if, for example, instead of just one line, we have maybe 3 or 4 lines of replacement, and we use the occurrence of the macro 400 times, that is 3 lines or 4 lines multiplied by 4, that means a total increase of 1200 to 1600 lines. In case of a function call, it would just be say 40 times we are calling the functions. We're just using for the function 40 times. But in case of a macro, it will be just the replacement, but the replacement will be 1200 to 1600 lines long. The 3-4 lines are 40 times we are calling it. We are having an increase of 300-400 times. Okay, so for example, calling a macro 40 times, macro of 4 lines 40 times, okay, 40 times will increase the program length by 1200 lines. Okay, that's the major issue. So where you have, so how do you use it? You've got the tools, now you do the balancing. If you have to have the flexibility of using any variable that you want, use a macro by all means. If the number of occurrences is less, use a macro by all means, because it speeds up the stuff. However, if you have to call it multiple number of times on any occasion whatsoever, then you decide on using a function. And in any case, a macro isn't exactly considered to be a part of the modularization process. You remember modularization, where the program is divided into small parts, each of which are doing some distinct activity. A macro is not a part of that. Only a function is a proper modular division of a because function is actually a piece of code that has its own memory and is going to be used as such. So it's only that. On the other hand, so for dividing it properly, use a function. For multiple calls, use a function. Multiple calls means a lot of calls, use a function. And where possible, if there are a few occurrences and you need to speed up execution, and you also need to have the flexibility of having being able to use different types of variables, use a macro by all means. Use it. Functions and macros, both, they should be used according to their advantages and with their disadvantages in mind. So how do you do it if you have multiple variables and you have to write functions? Well, you write two different functions with, say, two different names. One is taking float, one is taking integer. You use the float variation where the float is available, and use the integer variation where the integer is available. But in case of a macro, just one definition is going to be sufficient. As long as you have seen, you are not using any explicit typecasting. Now that is okay, you can do it. But weigh it out. Which one to use first? Are you going to use a function? When modularity is there, you use a function. When multiple occurrences of 40-50 times, you have to call it again and again, you have to call it across several files, you have to call it. By all means, use a function. Otherwise, you may choose, if there are 5-6 different types of occurrences of the same thing, then you may just write a macro. So you have to decide upon it yourself. However, a macro will not be considered as a proper division of code. Only a function is considered to be a proper module. Okay. So with this, we end today's lecture.